Welcome to Howdy Partner, a weekly Twitch series highlighting AWS Partner Network partner solutions partners that have built innovative solutions validated by AWS solutions architects such as myself. My name is Jeff Graham. I'm a partner solutions architect with AWS. Been with AWS going on 2 years. I'm currently based out of the DC area, and with me I have another PSA as my co-host. Would you like to introduce yourself, Hassan?
Yeah, thank you, Jeff. Good afternoon, everyone. My name's Hassan. I'm also a partner solutions architect working with Jeff's team. And yeah, I've been working for a year and some change now, based out of the New York offices, and very new to quantum in general. So very excited to see what this partner is bringing for us today.
So you mentioned quantum. That's an interesting word. So yes, you sort of spoiled it for us. Well, I'll let the cat out of the bag. Well, today we have a partner named LuxQuanta who uses quantum technology to safeguard the confidentiality of personal, institutional, and government data. And today we hear how they're using AWS services to do just that. But before we bring on our guest, let's talk about quantum technology and what AWS is doing in this space. Um, in the chat for audience, does anyone in the audience have any knowledge about quantum technology? If you do, put yes. If you don't, put no. And I'll give it a second, people to respond. But for those who don't know, let's set the level. Let's level the field and give everyone a base knowledge of what quantum technology is. So, quantum technology is an emerging field of physics and engineering. It encompasses technologies that rely on the properties of quantum mechanics. Technologies include computing, communications, and sensing. At AWS, we are investing in quantum computing and quantum communications. Let me bring up my slide. So at AWS, we're investing in the long-term potential of quantum technologies, and that comes in many forms. First, at AWS, we created and launched Amazon Braket. It's a fully managed service integrated with AWS Cloud that you can use today and gives access to a variety of quantum computers and really allows customers to test and experiment state-of-the-art hardware. Secondly, we launched a Amazon Quantum Solutions Lab, which is a professional services team of subject matter experts who can help AWS customers understand how they might leverage quantum technologies for their businesses. And third, and very importantly, to our overall approach to quantum technologies, in 2019, we launched the Center for Quantum Computing in partnership with Caltech. This is where we do research, development, with the goal of delivering a fault-tolerant quantum computer, excuse me. And last but not least, what we'll be talking to you more about today is the Center of Quantum Networking, where we do long-term research and development of technologies that we think could enable next-generation secure communications, especially in the cloud. The primary focus is in quantum key distribution, or QKD, which we'll be talking about a little bit later in more depth from our partners. So that is a 10,000-foot overview of quantum technologies at AWS. But let's bring on some subject matter experts who can talk a little bit more about quantum technologies, and then we'll have LuxQuanta who will talk about how they're using these quantum technologies to help safeguard our data. With us today, we have another AWS employee. We have Juan Moreno, a principal developer here at AWS. We have Vanessa Diaz, who is the CEO at LuxQuanta, as well as Alba Vendrell, who was a software engineer at, LuxQuanta, excuse me. But let me remove my slides so we can get our presenters. So let's start with the other Amazonian, Juan. Would you like to introduce yourself?
Hey Jeff, thanks very much for organizing this. Yes, my name is Juan Moreno. I've been with Amazon for a little bit more than 10 years, almost 11 years now. I'm a developer advocate, so I basically help customers to integrate with AWS, and my focus is on quantum technologies and particularly in quantum networks and quantum key distribution. I've been working with LuxQuanta for quite a bit now, and I'm very happy to be here on stage to say to the world the great things that they are doing.
All right. Thank you. Nice to meet you, Juan. Glad to have you on the show. Vanessa, would you like to introduce yourself?
Sure. Well, I'm Vanessa Diaz. I'm the CEO of LuxQuanta. As I've been very lucky to have been doing this job now for 3 years since the company was founded in 2021. My background is telecommunications engineering, but at some point I changed careers. I went into the dark side, more strategic, more commercial. And that's actually my previous work was precisely working with optical communication. So it was a very nice transition because I was developing new markets. This is a new market that it needs to be nurtured and developed. So far, so good, the journey in the quantum realm. A pleasure to be here with all of you, Jeff, and of course with Juan.
Uh,
It's an honor.
thank you for joining us. And when you say a new market, this is definitely a new market. So happy to learn more about it. And we have Alba Vendrell. Would you like to introduce yourself, Alba?
Hi. Thanks, Jeff. So yes, I'm Alba Vendrell. My background is in computer engineering with a master's in cybersecurity and data privacy, if I'm not wrong. And currently I work as a DevOps engineer within the LuxQuanta software team, focusing mainly on managing infrastructure for collaborative projects. And I'm excited to be here tonight to discuss and also to learn from the QQB experts.
Thank you. Thank you both for all of you for joining
No
us.
pressure.
Oh,
We got the label. There you go.
I wouldn't want to be an expert today. But before we jump into LuxQuanta and what you're doing with AWS to further secure our data with QKD, quantum key distribution, let's get to know a little bit more about you. So, Vanessa, how did you get into this quantum space?
Oh, well, it's a matter of luck. I actually was searching for a new adventure in my professional career, and Lux Quanta's opportunity showed up at the right time. Basically, one of Lux Quanta's investors is Corin, and I was working in precisely that was my previous company where I was working as a market development manager. So it was an old colleague of mine who will deny this in court, who proposed that maybe I could jump into this project. And for me, it was a no-brainer because if you are a deep nerd like I am, and you have the chance to work with something that you have been obsessed in documentaries for years, but something that is actually tangible because the technology that we are working with is real, is being installed, is being deployed, is being used. We'll talk about this later. You don't have to be actually any quantum expert. You just have to push a button and switch the systems on so they do the magic. I thought it was a unique opportunity. The team is amazing as well. You'll see later. Alba is one of our stars in the company. We are here thanks to her. Most of the work has been done thanks to her. So, I mean, and then you have the opportunity to grow a business almost from scratch. We plan to conquer the world and make this technology available for absolutely everyone who needs it. So, who can say no to that, right?
Yes, yes. Thank you. Very, very interesting and heartfelt. Excuse me. That's the word I'm looking for. So, Alba, superstar. What brought you to quantum?
That's what
Oh my
happens.
God.
You call people experts, then you get it back. It's like a boomerang.
I see. Okay, so for me, basically, it's my passion for cybersecurity technologies, collaborative R&D projects, and I would say also both data protection and management. And thanks to LuxQuanta, I can learn daily about QKD, the current paradigm, developments, and so on. I'm still not an expert in the QKD field, which I think it's even interesting for today's session. But yes, I'm passionate about learning, surrounding myself with interesting technologies that allow me to grow both individually and as part of a team. And honestly, it's not just marketing for LuxQuanta, but I'm so happy with everything it's offering me. And yeah, also working with this kind of tools and services like AWS, which I think is amazing for something with my background.
Okay,
So
cool.
yeah.
A
Thank
comment
you.
for the audience that was completely spontaneous. We didn't rehearse this, and I'm not giving Alba a bonus for saying that. But now that she mentioned it, I love that she say, she's a very good she has a very good expertise in the area that she's covering. But the beauty is that all of us in the company are learning from other aspects of the technology. So there is a place to work in quantum technologies. There is a place to work in LuxQuanta, and we're constantly asking for new talent. Okay, so I wanted to just leave that out there in case anyone thought that this project is worth exploring.
All right, good. So everybody watching, make sure you get your resumes updated. And Vanessa, you don't have to be an expert. All you have to do is be able to press a button. So get your, go to the LuxQuanta webpage.
I can
Listen,
testify it's a great team. That's true.
so you talked about what brought you into quantum. Can you tell us a little bit more about LuxQuanta? What started it, and what are you working on today? What type of endeavors?
Yeah, so the company was born 3 years ago, and it was born out of a research institution quite well positioned in the world. It's called ICFO, and they work with photonic sciences. They explore different areas. They also touch based on quantum computers, for example, and quantum communications. They have many areas that they are exploring. So they came up with this a bit more mature new version of quantum key distribution that it promised to make the deployment easier. Actually, for 3 years, our co-founders, almost 4 years, our co-founders were working on making it happen. There was a patent that had the idea of implementing quantum key distribution in a much more simpler way. And this captured the attention of some telcos that participated in one project, actually funded by the European Commission, that had as a target advance this technology into something that it was a prototype. So LuxQuanta comes out of that. So basically, we were born out of the research center, but with the input of large telcos like Telefonica, Orange, and Deutsche Telekom, who thought, well, perhaps this version could pave the way for making this technology more available for everyone. So then, born in May 2021, we secured the first investment round barely a month after we were born, and then we started recruiting. Actually, I was entering the company on month 6, and we were 6 employees at the time. The interview was pretty funny. I was the only one with didn't have a PhD, so I was like Wolowitz in Big Bang Theory. I'm just an engineer, and then from and then from there we grew into 27 team members now. So we have a very strong R&D team, and the company is also growing at way operations, the commercial. I would say that we've done an amazing thing because we have already released our first generation, our first CVQKD system. We'll talk later about what this acronym means. That was in February last year at Mobile World Congress Barcelona. And since we have deployed the technology across Europe and beyond quite successfully, actually. So it's exceptional journey. And this opportunity actually to be here with the audience today, showing the work that we've been doing with such a large entity like AWS on integrating, because like in life, you need friends and partners, and integrating with them is critical. It's great. I think it's a great opportunity for everyone out there to see that not only we exist, we're ready to supply.
Cool. Thank you. All right, Alba, I'm gonna make you earn this bonus. What do you like about working most about at LuxQuanta?
So maybe it's a basic response, but I love my team. We have we are all coming from the same place, but with really specific topics, each of us. And I think this is great for a team that it's small but still growing, because we can focus in what we really like, because either we have experience or we want to gain this experience. And yeah, here in general in LuxQuanta, we are an R&D company, so we are always open to providing new tools and new projects, and this is really nice for someone like me that is still learning what I really want to do, or already knows some things I'd really love to do. And yeah, this is really nice.
Great answer. Great answer. All right. Were you about to say something, Vanessa?
I was gonna say, yeah, but I thought you were say it's a lot of hard work, but it's fun. I
Yeah.
want to believe because it is hard work. I mean, being a startup, it's intense. It's very exciting though. So at the end of the day, I think we end up with a great sense of accomplishment.
Okay.
Exactly. And also, something really important to think about is that we are in a really interesting field. And I think this is something nice for all of us because we always feel like the motivation to keep learning and don't get stuck in something that might be seen like the standard, let's say, but we always need to go and move one step. And yeah.
Okay.
Actually, it's a very dynamic team, so things change very fast in this company, and
Daily.
the advancements we are making at R&D level, any level, it's not because I'm there and I'm seeing it, I'm living it, is because genuinely I'm impressed. I come from a commodity market and a large entity. I knew that startups were agile and fast, but I never expected to see anything like this. And it's because the team is genuinely outstanding. We're very lucky.
Okay. Cool. So I know that we're talking with LuxQuanta today, but I do want to take a quick segue and get Juan into the conversation and ask him how did he get into quantum, and then he can tell us a little bit about QKD, and he can pass it on to LuxQuanta to get started.
Sure. Thank you, Jeff. Well, I've been around for a long time in AWS, and one thing that this company has taught me is that it rewards curiosity, right? I've been in a bunch of teams and doing a lot of roles in my tenure over here across 2 countries as well. And AWS always gave me that flexibility to move around. And as long as you have passion to learn about technology, you always find support and ways to keep learning and keep growing. So I was a solutions architect manager when we announced Amazon Bracket, the service that you were mentioning before, for which we give access to customers to quantum computers. And as a solutions architect, they said, what the hell is this bracket thing? Let me try it, as I do with every new service that the company launches, right? Run the hello world example, understand the logic, and you want to be able to speak with a little bit of credibility when you talk to customers about it, right? And I realized that, oh, this is noisy too. This is very different to anything I have touched before. And I realized how heavily it was based in physics, that it was an old hobby, a frustrated old hobby from me that I never completely pursued. And I started to get more into the theoretical part of it and in quantum physics. Started to collaborate with the team and eventually made the change and started to work with the Bracket team as a solutions architect. Right? And from there, it's been like going in motorbike. It's been an amazing journey, learning a lot every day. The company started the Center for Quantum Networks that you introduced as well. And there was a good opportunity to help over there, especially to bridge that gap between the academic world and the research space and an enterprise and the business world, right? And trying to bridge that gap and start making integrations as much as we can with quantum networks. And that's something that probably makes my team unique. I'm part of the quantum networking team, and we don't have a service attached to us. In the same way that in quantum computing we have Amazon Bracket, in quantum networks there's not a specific service that we say, well, we offer quantum key distribution as a service or anything like that. However, we are doing research and we are investigating the space, and we want to see how customers could integrate with this technology because we see the importance of it for the reasons that we are going to discuss with Vanessa in a minute. So basically what I do is try to bring QKD as close as possible to the AWS edge, and my team is testing every single device out there that exists in the market that is commercially available to see how they work, how could they work for us in the future if we decide to offer QKD to customers one day. And my main focus is in basically quantum key distribution integration at AWS. So we have said this word a million times, and probably people are trying to figure out what the hell is that, or not everyone is familiar with cryptography. But I will say very briefly that when we talk about QKD, we are talking about a secure communication method that is using the properties of quantum mechanics to exchange encryption keys. It's creating keys that we are using for encryption, and it makes sure, and that's what makes it a little bit different or special, that if there's any eavesdropping attempt in the network to grab these keys, it will be immediately detected. And that's what makes it special. So it's also using qubits. If someone in the audience is familiar with quantum computers, they heard about qubits before, but it's a special type of qubit. We don't do gates and circuits and all those things like in computation, because we don't use it for compute. As I said, we use them to create keys. So our qubits are photons usually, and those photons are mapped into a key that is, as we say, theoretically unbreakable, and that gives us a very high level of security for data transmission. I think that's in a nutshell. But in cryptography, there is a lot of buzz and a lot of noise right now, and we keep hearing that cryptography is at risk, that the RSA is going to be broken, that our data is going to be insecure in the future, and we want to clarify all those things before start talking probably about specifically what LuxQuanta is doing, because that will help to level set the conversation. So probably this is the best point in which I can let Vanessa explain what is that all about, why people are talking so much about the risk on cryptography.
Vanessa, real quick though, you put a plug out for people to join LuxQuanta, and we have a question. Do you want an AWS Solutions Architect Associate on your team? Exam.
I can think right away about one job that probably we will be releasing towards the end of the year, and this might actually fit beautifully. So I'm gonna go with yes, and I'm gonna encourage this person to have a look at our LinkedIn, please, because we release all the new jobs there, and send your CV across, please.
All right. Good luck. All right, back to you, Vanessa.
Okay, Juan, you've done a beautiful intro, and it's a great summary. One thing that I was thinking we could do is maybe go step by step, in even more simple steps for those in the audience who do not understand the very basics. So starting with cryptography. So let's say that you and I, Juan, we want to talk, and we want to talk privately. And that means that we're going to have to use a specific language, or we need to code the information, or we use a password, something that prevents others who could intercept that communication to learn what exactly we're discussing, what we're talking about. And this is the fundamental principle of cryptography. So it protects literally all our digital communications. And this is everything that happens between as big as governments and private companies, but it's also citizens as well. Historically, a best case scenario, it will be if Juan and I want to communicate, we actually meet together somewhere in the Atlantic for a beer, and then we just agree on that password or that criteria that we're going to use to hide or encrypt our communications. That would be the best scenario. So actually that is called symmetric cryptography. And that was practical back in the days when we did not have internet, because right now we communicate everyone with everyone. So that is not practical anymore. So that's why we invented asymmetric cryptography. So I'm going to share a slide that I hope that helps a lot to explain this. This is the example that actually one of our software engineers, actually the person that Alba reports to, Marco, he explained to me when I first joined the company. So it's a nice metaphor. Let's say that these two computers represent Juan and myself. So Juan has the information to share with me, and I have a password that it exists as a combination of a private key and a public key. So what I do is send the public key, the lock that is open to Juan. Juan uses that lock to encrypt the information. It goes through the network across the world. Nobody can open that message because the only person who has the private key is me. So that's why it's called asymmetric, because Juan actually has no keys and I have two. Now, everyone in the audience probably is thinking, same as someone cracking or hacking a safety box. If you look at that lock, you could potentially extrapolate what the private key is. And this is the risk. it can be done. So what it leaves behind that lock is actually a mathematical the result of a mathematical problem that is very hard to solve for, not hard. It takes a long time for occurring the computational capacity that we have today. One of the most common mathematical problem used out there is the multiplication of two very large prime numbers. So the two very large prime numbers will be the private key, and the result of that operation, it will be the lock. The computation that we have today takes 40 years to just, if you intercept one message, undo that problem. But the risk is there. Actually, throughout history, the complexity of the mathematical problems used, like this one, with prime numbers, has been reinforced. And there is always, we're looking into machine learning, we're looking into artificial intelligence. Europol was releasing a report literally a few weeks ago talking about those two tools being used to reinforce our cryptography, but also potentially being used to hack our cryptography. And there is, of course, the certainty that once quantum computers reach certain capacity, there is already an algorithm invented by a gentleman called Shor, that once the capacity is there in these quantum computers, it will be able to hack the cryptography. So what does this mean for us all? This means that all our security, all our cybersecurity, or all our digital communications could be exposed. This is a huge risk. And this is the reason why the world is realizing that the time to act is now. Because at the end, we're talking about confronting a problem that impacts all our digital communications, all our networks. So you need to upgrade your infrastructure to something that is quantum secure. That's the way that you normally heat it out there. So you can withstand the attack of anything that could come in the short term and in the medium term, like a quantum computer. And that takes time. So if you look at Q day, the day that everything is going to be hacked, cryptography, and you walk all the way back, large organizations introducing the solution, it literally brings us to today.
That's something that I, Vanessa, find usually many customers sometimes do not understand completely, right? The fact that the data that is being encrypted today with traditional methods could be decrypted in the future when a quantum computer exists, right? So the question about, oh, should I worry about this problem when the quantum computer exists? Why should I start caring about it now? It's not really that relevant because, yeah, if you are dealing with, I don't know, government data or medical records or things that needs to be stored for 10, 15 years or even more, someone could be getting your data today, right? And that's something that, for that reason, is a good idea to start taking actions now.
Thanks for pointing that out. Some in the audience might have heard about that type of attack. It's called harvest now, decrypt later, when you have the tools to hack it. That's correct. And then there is this certainty we were talking about. I mean, the need of, I said, confronting this problem and do something about it is a must now, because if you look at the huge amount of investment around the world in quantum computing, but also how artificial intelligence is also ramping up in complexity and capacity, the reality is that it's not a matter of if, it's a matter of when. So problem to be addressed today. So that will be step one. So we know what cryptography is. We understand asymmetric cryptography. And then we can go into how can we solve then the problem that we have on the table. So the first natural approach, it would be, let's find a harder to solve mathematical problem. And this is what the National Security Agency in the US, NIST, has been doing over the last few years. So they literally run a contest asking the most privileged minds in the world to come up with a mathematical problem that it could withstand the attack of a quantum computer. So there's been finally announced the finalists. So many of you might have heard about Kyber. I love the names that we give in the industry. It's so super cool and super nerd. And that is based on lattice curves. So it's a mathematical problem that theoretically is going to be able to cope with a quantum computer attacking the cryptography. So this is what we like to call as a software-based kind of solution. So it's something that is very It's very smart to do if you want to start right now with something that helps you prepare, because the transition is supposed to be relatively more similar to what the cybersecurity experts are more used to do, right? The question is whether this is the solution for all and is the solution forever. There is always this question about whether a quantum computer eventually might be able to hack it, and then we will see ourselves reinforcing the complexity of these problems, mathematical problems, same as we did in the past. We have been doing with the cryptography that we have today. And so there is another approach, and this is what we've come to tell you about, and it's called quantum key distribution. So I'm going to share a different slide now, and I'm going to explain what this is about. If you understand this, that's it. You are quantum experts. That's all you need to do, to know, at least in quantum communications.
I love it.
Okay, so now what you're looking at is you're going to see again the two computers, Juan's and mine's, and then you see an extra layer, because this solution is called hardware based. So we need to add another layer of devices, and those are the ones that you see at the bottom. Actually, when we say that we sell a system, a quantum key distribution system, this means a transmitter and a receiver, also called sometimes Alice and Bob. So that extra layer is going to use if an optical fiber to send the information of a key coded in the light, coded in the photons. At the end, what you have is literally an optical signal that what we do is I like to say we attenuate it a lot. So it stops behaving in a deterministic way, like we know things, and enters into the quantum realm. In the quantum realm, if you have a particle there, in this case, a photon, if you observe that particle collapses in one state. Okay, it sounds like magic, but actually that happens. So this eavesdropper, as is normally called, it leaves a trace that has intercepted the information that I was sharing with Juan to build the key. If the channel was clean, then the two systems can now, using a different channel, start gossiping, and then together they distill a quantum key that is passed to the upper levels of the system or the applications above. Imagine that this was a VPN, so the VPN, virtual private network, it could be using these keys that are symmetrical. So at the end, one way to understand this is the equivalent to what some governmental agencies are doing, or the defense the departments of the governments are doing. And it's literally a person, a professional, who's carrying a suitcase with the keys inside from one place to the other. So this is the replacement. That's why sometimes you will hear me saying that this is some kind of like a James Bond quantum solution, right? So I make sure that the keys go from one side to the other and it's perfectly secure. So that's why this is the basic. Actually, the name says it all. Quantum key distribution. I distribute a keys, cryptographic keys, protecting it with the laws of quantum physics. And this is the distinctive feature of this technology. I protect the keys not with a mathematical problem, but with the laws of quantum physics. So I don't care what's the computational capacity of my adversary, because it's not about that. It's about leaving a trace, because quantum physics are there, to give me that security. So this is why this is a solution that is, we like to say, future-proof.
I have a question there, Vanessa. So I see that this goes point to point. Is your what we usually call Alice and Bob, right? In exchanging this information. Well, it's going to be Juan and Vanessa in this case. We change the guys. So if for customers that are running in massive data centers with hundreds of thousands of switches and routers in their network, do I need to buy pairs to cover every single connection within my data center, or it seems like it's difficult to scale, right? If I have to protect an entire network this way.
Yeah, we will see there is ultimately the way that this solution will be deployed will be like a mesh. So there will be the telcos around the world are already looking into this as a mass deployment. So then you and I, Juan, could communicate across the city, and you will have literally a network of these devices. So you could go from side to side. For a data center manager, you could apply the same principle, and you could be like a daisy chain of Alice's and Bob's. Some manufacturers, that's the case of LuxQuanta, we can offer point to multi-point connectivity. So you could have one Alice, for example, living in the data center, and then many Bobs in different places, potentially the customers of this data
Oh, I
center
see what you mean. Got
connected
it.
with it.
So it's not so much that you are gonna protect everything inside your data center, but QKD is gonna be used for those critical links that go outside from your data center to the outside world, where the biggest risk is, right? To your
Correct,
customer.
exactly.
Ah, right.
Yeah, exactly. I mean, at the end, this is a technology that protects the information in transit. So you need to identify which of those links that you have are more exposed to a hacker, like literally someone tapping into the communications. Those are the links that's what we're actually seeing. So we're working with governmental entities and private companies, and every always starts data center companies as well. It always starts with a consultancy kind of work. So what is the biggest risk? I like to say that at the end, imagine that you have water pipes and you have a pipe that is huge, because the amount of data that is just running up and back and forth through that pipe is brutal. That is a good place to start with. Or, for example, the type of information for a governmental entity, maybe the information is extremely confidential. That is the link that we need to address first. Eventually, you will be able to have it everywhere. Of course, we are working on that, the manufacturers.
Got it. So it's like you cannot have a policeman in every 100 meters when you are doing communicating outside of a data center to other places. And theoretically, someone could just dig a tunnel, or if you are doing it underground, and grab your cable. And with traditional technologies, I can do, I don't know, maybe a port mirroring in a switch or something like that, and start getting a copy of all the data, and nobody will notice on the other side, right? But with QKD, that makes it completely impossible, because you said that the quantum state will change and it will be detected immediately, right?
Exactly. Actually, the way we see this technology is we will see this technology being used in combination with harder to solve mathematical problems. People out there might have heard about the name post-quantum cryptography. It's a lot of acronyms and it's easy to get lost. It took me almost like a year to get comfy with them. But at the end, is no one solution fits everything. So we will see hybrid combination of these two technologies. So, for example, a very clean example of when it makes more sense to go for Kyber, no? This post-quantum cryptography algorithm. If we have something that is wireless. So if I have a connection with my mobile phone in the tower, that's a great example where post-quantum cryptography makes sense. Whereas if we're talking about very delicate links where there is an optical fiber connecting both locations, that's where quantum key distribution makes a lot of sense.
Actually, I see them as a complement, maybe. Like people sometimes call us a defense in depth, where you have your PQC established, and then you add in those critical links that layer of extra security with QKD. For PQC, it's probably the second most asked questions by customers, right? People get confused with the word quantum in post-quantum cryptography. There's nothing quantum about PQC.
No.
It's just the fact that it's meant to be for the post-quantum era, and that's why it has that name. We have an AWS cryptography team. It's not my team, but it's a large team in AWS that is actually one of the contributors on the Kyber Cipher Suite. And we have offered that to customers in some of our services if they want to start testing it. It's available in Secrets Manager, in our KMS service, and also in, I have a third in mind, but I'm not going to say it just in case. It's better to look it up. But we are starting to offer it in a trial capacity to our customers if they want to start testing performance, and if the encryption is as effective as any methods that they are using today. So that's an option that customers can start using already in AWS.
We can actually
Also,
go.
Vanessa,
Yeah.
could you hear me? Yeah, Vanessa,
Yes.
I also had a question. I appreciate the explanation. I think I definitely understand the significance of this technology a lot more. But I was just curious about like the typical latency and throughput rates associated with these QKD systems compared to like the classical encryption methods we talked about. Like, how would this process be end to end? And yeah. kind of, I guess, relates to that scaling question Juan was asking.
Fantastic question. The beauty is that because we create symmetric keys, extremely safe, extremely secure, at the end, what we have is the two devices, the transmitter and the receiver, Alice and Bob, constantly creating keys. That's their job. Actually, these machines have to be working 24/7. That's why reliability is critical. Keep feeding basically a bag of with quantum keys. So those keys are passed on to the applications or the encryptors or the devices above, so they can be used to encrypt the information. So this means that I am not using a one-time pad kind of cryptography where I'm coding every or encrypting every word. I can use those keys because they are so strong for a lot longer. So you have different criteria actually out there that tell you, depending on the information that you are exchanging, depending on the application that you are using, there is a recommendation, same as there is today with current cryptography, about how the keys should be, how often should be refreshed. So that's the reason why the throughput of this technology, quantum key distribution, is not that critical. So you hear us manufacturers talking about a few dozens of kilobits per second, and that is enough to do the job. If that answers the question.
Yeah, no, that did. Thank you.
The work continues, though. I mean, there is a lot of aspects on this technology that the manufacturers keep working on and improving. We said at the beginning that this technology is ready to be deployed. So, but that does not mean that we are still making it a lot more in terms of performances, no, a lot more in tune with what the customers need out there. So actually, one question that the audience might have is what is different about what we do versus what already exists? Because this is quantum key distribution has been in the market now for quite a while, and there is a new flavor of this technology that LuxQuanta is working on. And I mentioned the acronym before, so if you are with me, I can share a slide as well, and I can show you the differences between the traditional, the old version, and what we work with right now. So bear with me. You'll see the slides now. So the difference, or the two main technologies that are out there are called discrete variable QKD or DVQKD and continuous variable QKD. That's the one that we work with. So the difference between these two technologies is it boils down to how you put the zeros and one of the cryptographic key into the light. So if you take the photon and you use a property on the photon, like the spin, to code the zeros and the ones, then in the receiver, you are going to need a single photon detector. And this is a machine that is like a whale. As soon as it detects some light, it just opens and is very sensitive and it reads everything. So this receiver, the component in the receiver, the single photon detector, is great in terms of sensitivity. So you can cover very long distances with this technology. You hear out there over 100 kilometers, but it does come with some trade-offs because you cannot have other information, other light running in other channels within the same optical fiber. That can create a problem, right? And then also the single photon detectors, they need cooling too. So that's another aspect that makes them a little bit more delicate. So any technology out there that is having these kind of receivers, and I'm referring to some other versions like entanglement, at the end they deliver the same kind of benefits and limitations. So what we work with is a new version. It's called continuous variable QKD, and what we've brought is bringing into quantum key distribution exactly the same we do in the telecommunication industry. We are not coding the information in a photon. We are coding the information of the key in the entire signal. We are modulating the phase and the amplitude. That allows us to have a detector it uses coherent detection. And that it's like a sniper. So we can actually look within the optical fiber, a specific channel where the quantum information is arriving, and then just select only that. So it makes the technology, first of all, extremely good to coexist with data. This is great. So if we bring the example of a data center manager, if this data center has one big pipe, one optical fiber connecting to the network, and there is one optical fiber available, we do not need anything but just a channel within, and this is great.
Oh,
This
that's
is
very cool, right? Because there are many telcos that have deployed networks in metropolitan areas where it's not possible to expand anymore, right? So
exactly.
you need to use what you have and work with dirty networks that have been there for maybe 20 years, and that's all you have. And you cannot interrupt the existing classical traffic, let's call it.
Exactly. So actually, this is extremely valued. It's one of the things that made the technology so interesting up in its birth, and the reason why we've been selected by many end users out there, because precisely this added value. So this is actually a bit complex, maybe for the audience. Is I'm just showing the how the optical fiber behaves in terms of attenuation. No? So normally the attenuation here is very low in this band, and this is where normally the optical networks are deployed because the optical fiber offers very little resistance. So then you can go longer distances. So all the systems are normally deployed in that band. So ideally, you want the quantum key distribution to be operating as well in the same band, because everything else is just designed to operate in there. And that's precisely what we can offer, is coexistence in the same space as the data. Actually, we can have the data and the quantum channel extremely close. Also, this technology delivers zero touch integration. So it's first of all is what I said at the beginning. You can literally push a button, and then the integration, it takes barely an hour. We have deployed these systems across the world, and we've never had to be on site to help our customers with the deployment. We do it remotely, and so far so good. So this is one of the reasons why, for example, telcos like Telefonica believe this technology is fantastic for particularly metropolitan networks. No, what you were saying, each customer has one fiber available, so that be it. And actually, it's great because our maximum distance around 60 kilometers is around today, which is perfect for this kind of networks.
Right. I think that important that people understands that, right? For those of you who have worked in data centers and are familiar with the structure of a fiber cable, it's basically we are using the same things that are using for regular data. The way it was explained to me, and I like it, is thinking on the channels on TV, right? You have one single device and you can just tune in different channels to do different things. This is a similar concept in the sense that the C band, the O band are within the same physical cable that you can use. So for deployability, as you are saying, your technology seems to be very flexible. Yeah?
Very flexible. And the other aspect is that it's very reliable, because we don't have single photon detectors, so they are a little bit delicate. All the components that we use to assemble the technology that we sell out there is very mature. It's off the shelf. You literally buy it in any website that sells optical components. So this makes it extremely reliable. And this is very important because if
So
we
cool.
look at these environments like a data center, a central office, one aspect that it makes this environment very critical is the temperature. So actually there is a quote here from Verizon. There was a conference they were giving. They were talking about precisely the temperatures ranging from -5 to up to 50 degrees Celsius. So you cannot ideally have a device. You should not. I mean, it's best if you don't have devices inside your machine that need cooling and everything is telecom grade, like our case. Remember that these systems have to be working 24/7. So reliability, we knew before we were born, and it's confirmed with our customers that this is fundamental. And this is where our technology differentiates from what's out there in the market. I'm going to stop sharing the screen.
Awesome.
Okay, that's a question. We're mentioning, keep mentioning fiber optic networks. Is there a specific fiber optic network infrastructure needed to implement a QKD system?
No, I love the question, Jeff. No, so the vendors in general, so what we are delivering here with quantum key distribution is a solution that integrates in the optical networks that we already have. It's true that if you look at the old version of the technology, if you want to see it performing at its best, so to say, so the maximum distances they reach, they will ask you to give them a dedicated optical fiber. So in some links that might be a little bit challenging, whereas we can coexist with the data. So literally the example we said before, you have only one optical fiber really available. That's the space for us, no? But nothing new. It integrates in the existing optical networks. That's what we are seeing actually being deployed.
Cool. Great. Yeah.
Mm.
Maybe we could talk a little bit, Vanessa, about the keys themselves, right? Because when you start thinking about this, the QKD boxes are generating keys constantly, and there must be some certain demand on the network, right? Especially on those scenarios that you were describing, where you install several devices and they are interconnected in certain ways. There must be some parts on the networks that are claiming or reclaiming more keys, and maybe though the QKD devices on on those areas are not providing as many as the device downstream devices require, but in other parts of the network you might have the opposite problem. So I think we have to start seeing how people are trying to test some kind of management layer where you can move the keys around with a little bit of freedom, and in the context of software defined networks as well. And I know you have had a lot of battles with this and talks to customers. It would be great if you can share your experience on where is this field going.
See, I love it. And another excellent question for the audience to understand exactly how this technology integrates. I'm showing a schematic on how communication between 2 points, in this case, is a video conference, looks like. So it's a video conference between two entities. So the video conference here, it was programmed by Telsey. So that's the upper layer, and that's what we are protecting with what's happening at the very bottom. So what you see there is different logos from different QKD vendors. So you will see there LuxQuanta, right? So you have 3 steps or 3 nodes. So right above the quantum key distribution links, you see another layer. In this case, it's one of our partners, CoolNet. They work with what Juan is precisely referring to. It's a key management system, because at the end, as soon as you move away from a point-to-point kind of link where it's just one Alice and one Bob, they can coordinate themselves beautifully. But as soon as you have a much wider party and you have a more complex network, there are all different links with different keys. So it's like going across a house, having to open multiple doors. So you need an extra layer that it gives you the combination of keys that you need, and make sure that there is enough keys in each node of the network at a given time. That's the key management system. That's
There are
what
two
their
things in
job,
this picture that I love and that we
right?
haven't mentioned so far. Number one, the interoperability, right? I see logos from other
Mhm.
people there besides LuxQuanta. So it tells you that at the end of the day, QKD devices from different vendors are providing keys, and the key management layer that we see there is basically making sure that it's transparent for the downstream devices. And that's something super important for the audience, probably, for them to know that they are not going to have to do any modification in the application layer or in the operating system layer if they want to consume these keys. Obviously, um, the, there's the need to be an awareness that this technology is being used, but the operating system doesn't need to know where the key is coming from. They don't care if it's a quantum key or otherwise, right?
Exactly. It's completely transparent. And this is actually one of the best demonstrations we could have made throughout this year. We actually did this twice for the European Commission in 2 different conferences. And it was precisely that one. The objective of this is just making sure people understood that when you acquire quantum key distribution devices, you are not sold to one vendors only. They can actually be combined. And this example, these 2 demonstrations were were just a guarantee of that, basically. So it's 4 different QKD vendors coexisting in 2 different links, so to say. No, and then the KMS governing everything. So there are many entities working in that layer as well, on the KMS layer, and we are all making sure all the time that we can work all together. There's a big effort in the industry between all the key players, so the QKD manufacturers, the KMS vendors. You see another layer in that example. That's the encryptors, in this case from Rodersbath. There is also integration with them. And there is also integration in this case, or we're talking about SDN networks. Ideally, we want to make sure that, as you introduced, Juan, everything is completely transparent. So that actually brings us very close to what we did for the integration with you guys, with AWS, is how can we gather all the information from a QKD link and then show it into monitor it, right? So that the AWS customers could actually have access through AWS instances to what is happening at the QKD kind of layer, no? Completely integrated all together.
Right. So for a regular system admin that is in a monitoring center, how can we make sure that we make QKD just part of that? And if you have a complex network like this one you have over here with several vendors, how do you aggregate the information that everything that is happening in the QKD layer of your network? And what are the relevant metrics? We don't know anything about that, right? And that's what, yeah, we have been working together on that. That's pretty cool. I think this is the. Go ahead.
See, this is the kingdom of Alba actually, because she's the one that can give us a hand on understanding what exactly comes out from a quantum key distribution link in terms of parameters. So what is relevant, what is not, what is this monitoring now that we've been talking about? You ready to rock and roll, Alba?
Yes. So
Okay.
thanks. It was really interesting discussion, guys. So yes, if you want, we can now jump and talk a bit about monitoring, metadata, key performance metrics, and so on.
Yeah, that would be awesome.
Yes, first of all, just a bit of context. Maybe it's important to mention how are we as LuxQuanta integrating with AWS. So in QKD, monitoring metadata and key performance metrics it's essential and crucial. Basically for ensuring system reliability, security, and all these kinds of important metrics and yeah. So AWS offers a powerful platform with robust cloud services for our monitoring capabilities. So we basically delved into developing a formal solution with the cloud services of AWS, which allowed us to scale, scale automatically, and manage also this kind of long-term data rotation metrics, let's say, effortlessly.
Mm-hmm.
And I will share my screen in a few minutes, so you can also see a dashboard that we prepared, so you can also understand which kind of metrics are we talking about and so on. So we had Grafana instances running on basically traditional systems, among other needed services for data aggregation and alarming and so on. But they were limited, as I mentioned, in terms of how many hours could be stored and the ability to aggregate information for various sources into a single dashboard. You know, all the inconvenience of traditional systems, basically. Nothing new for us. So the cloud was a good solution for this use case because it allows us to consolidate multiple systems into one location. And this is really important for QKD and also for what we expect from QKD in the future. So with this, we don't need to worry about maintaining physical systems because basically the cloud provides the flexibility to handle all of these kind of things for us. And as you know, AWS is very mature and easy to set up, and it's even easier with Juan's help. And yes, in case you are wondering, no, the data we send does not include critical information such as confidential data, sensitive information in any way. So we just basically send telemetry data, which is encrypted using encryption methods, traditional and standard encryption methods. And yes, only the monitoring data itself is transmitted, which is safe to send to AWS.
All right, that's important, right? So
Yeah.
really what you are sending to AWS for our services and to show the Grafana boards is not actual keys or these things that we have been discussing in the quantum channel and things like that, right? It's the actual classical metadata that tells us how the device is doing, but not the actual key, right?
Exactly. Yeah.
Oh.
This, for the moment, it's safer to keep it in just one box. So we just send the data and the metrics that we actually need for the monitoring itself. And yes, just trying to get all the good things that AWS is as cloud service provider is providing us.
Got it.
So yeah, basically the main goal is to ensure the, let's say, system integrity. And how? Telemetry, monitoring, and alarming, among others. But this is the topic we want to discuss today. So these ones are crucial for maintaining the integrity of the QKD. And it's really important for the actual experts that are going to handle this data to have a comprehensive way and visual way to see the data. And that's why we use, for example, Grafana, Prometheus, all the exporters, and so on. This will allow us, and this is actually allowing us, to have a real-time oversight of both the quantum and the classical channels, detecting anomalies and potential breaches, and as they occur, in real time. So this is crucial. And yes, so said so. This is something maybe you already knew, but yeah, it's something important to mention. And I think we can jump into the dashboards that we prepared. We can see there the metrics that we use. We can just give a couple of a brief description of each of them. And then
I can't wait. I can't wait to see that dashboard.
So yeah, I'm going to share my screen now. Let's see if I do it correctly. And
I think 320 questions are gonna pop up to my head as soon as I see the dashboard.
Okay, I think I'm sharing my screen now. If someone could
Nice.
confirm that you can see
There
it.
we go.
Yes.
Okay, so yeah, here on the screen you will see this dashboard we prepared. They display, as I mentioned already, the real-time data about the QKD systems. And I don't want to go into extreme detail, but I want to give a bit of context about what we are going to see in the panels. Because visual representation is more engaging than just words. So basically, it's really important for us to talk about the excess noise, control the excess noise. It's a really important metric which basically measures all the extra unwanted noise in the system. Is basically all the noise that we can't model and correct for. So we attribute it all to the attacker. Maybe there is no attacker, and that noise would be possible, but we just discard it, which makes the protocol always safe. Cool. This is also correlated to the B mode, which is normalized measure of the excess noise relative to the shot noise, which is basically the level of noise inherent in the quantum measurements due to the discrete nature of the photons. And yeah, this facilitates comparison and analysis for the experts that see these dashboards.
So connecting it with what we were saying before, Alpha, is because we were saying the information of the keys is coded in the optical signal, and then we attenuate it a lot. So that's why Alba is all the time talking about noise, because I like to say we are like whispering in the optical fiber. We are sending the information with the key, whispering with the optical light. And what Alba is showing there is the graphs where we are monitoring that nobody else is freaking whispering in the same channel or introducing any kind of noise, because that means that there is an intruder.
Exactly. For example, sorry, Vanessa, here we see something going really up, then we can talk about. I mean, this should not happen because we have the post-processing for something. But yeah, this is something monitoring always.
But it's useful on itself, right? So
exactly.
If you see that some of the dots that we see here are going up to the roof, maybe it's a system malfunction as well, even if it's not an attack that we need to take care of, right? For a system administrator, it will be super important.
Exactly. This is also important for system administrators, as you mentioned, because, for example, we are using services that maybe they are not compromised, but the service can stop because there are always things happening. And it's also important for us in order to be able to check the logs and so on, to see the uptime of the systems as well.
Gotcha.
So yeah, these are really important metrics. This secret key rate, I think I don't need to explain anything about this one, but this tells us how fast the QKD system can produce these secure keys that keep the information safe. And this is something I hear a lot. In LuxQuanta, they are always talking about the secret key rate because it's really important to always try to achieve a faster secret key rate. And this is dependent to many, many, many different topics. And depending on the partnership or the client, we have different properties, we have different systems, and we always try to achieve what we expect to be a good secret key rate.
Actually, you nail it there on saying that, Alba, because we say that the system that we sell, Nova LQ, is plug and play, and this is one aspect of the plug and playness. So literally you connect it to your optical fiber link in both sides, and then the system assesses the characteristics of that optical fiber and adjusts all the internal functioning in the parameters. So the key rate that you, Alba, are describing, it goes at as its best level. And actually, if you unplug the machines and you plug them into a different optical link, they just readjust in a few minutes, and they are back at as its best, right?
This is amazing, I would say.
It's magic, right?
Magic.
And it depends on a bunch of factors. That's it's difficult to tell, oh, you're going to get this key rate when you plug your systems, right? You need to do like measurements on the network to figure out the distances and who's on the other side and the noise on the network, the crosstalk.
Actually, it's a very good point. Normally, QKD devices, the further apart they are from each other, the lower the key rate, because at the end the signal it gets weaker. So you need to storage more information in order to create a key or agree on a key. So you need to wait a little bit longer because you cannot hear very well. So it's like
I like the torch example, the flashlight, because it's more close to photons, right? And you are pointing with your torch, and the farther you try to reach, at the end you don't see any lights, right? It's not you cannot see what's in there. So it's a bit similar in that sense. The photons fade away.
And this is actually when we were saying before, so what's the maximum distance of the technologies is based on this. So it's how far apart we can put the transmitter and the receiver, Alice and Bob, so they can still see each other, right? And then create these keys. But connected to the question before that we were commenting here, it's still, even if you put the systems as far as possible, up to its limit. So in our case right now, it's around 60 kilometers distance. The key rate that you get is still enough to operate on the applications above because of what we were saying before. They are so secure, so safe that you don't have to refresh them so often. So that's why we set that maximum distance to a point where you still have at least a minimum of a standard key per second. Sorry, Alba, we have hijacked that
Yeah,
first
yeah.
mention.
I
So
think
let's
it's
go back.
perfect. It's perfect. It's perfect because also you were mentioning regarding distance and so on. And this is basically transmittance, which tells us how much signal is lost over distance, because basically measures how well the quantum signal travels through the whole system. And yes, regarding post-processing, I love the post-processing. My supervisor is an expert of post-processing, and he's always teaching me interesting things. This is the real magic of all the system, I would say. This shows how often mistakes happen when the system is fixing and refining the raw data that it's coming to the post-processing in order to create the final secure keys. So, magic, yes. And last but not least, the detection noise is all the unwanted signals that are picked up by the detectors that we have in the QKD systems. And these ones can come from various sources, such as electronic noise within the detector itself or external environmental noises. And with this, we could confirm that the system has been up and running properly for the last 3 hours or the last 2 days or whatever we need. And
Wow.
why this is important? Yeah, there are many dots and many lines, and looks really, really good. So yeah, these values looks excellent, but however, this is not the main focus. What's more important is the significance of monitoring itself as its impact on overall the system reliability and security. And for QKD, as we already mentioned, this is crucial. So it helps us ensuring that the performance is what we expect it to be. This is really important because we have clients that we have synced with them that we are going to be producing some final metrics, and we need to be aligned with them. And as system administrators, it's essential to monitor these parameters to maintain all the efficiency of the network. And even if you are not an expert in quantum technology, this is what we were talking about. We can consider this kind of projects as a plug and play, because the complexity here should not be high. And so basically our approach is to simplify all this integration and treat considering the QKD system like any other network device, such as a switch or a router or whatever, making it more manageable. And with this monitoring solution, you just need to know where the what we mentioned the other day, the power button is, and everything else is streamlined. So yeah, I would say this approach not only ensures secure encryption, but also simplifies the integration process itself by leveraging the infrastructure as a code with tools like we use, for example, AWS CDK. And we have made the setup and management of the system much more accessible, I would say. And at the same time, as the infrastructure is managed through code, we can version, we can track changes, and we can do all these kind of tasks that we daily do as software engineers, but easily. And also, we guarantee that the configurations are consistent. We make it easy to deploy, we make it easy to redeploy, and also to maintain the stability, because what we have here is just a Grafana for one node, but in the future we expect to have 1,000 nodes and we don't want 1,000 Grafanas, and we don't want 1,000 petabytes of storage in our laboratories, because this is not something we can handle. So that's why we rely in tools such as cloud services AWS, because this is what it's incoming, and we need to have somehow solution already tested, just to make sure that what we expect in the future is going to be doable. So I would say this solution could be summarized as: I'm just a sysadmin, and my strength is in ensuring smooth system operations. I'm not an expert of QKD. I just have clear visibility into what's happening on the network, because this is important for all of us. And yes, we can aggregate more systems. We can auto-scale the front end using a gold image, whatever you decide to go through. And it's easy for both the sysadmins, it's easy for the clients, for the partners, for the end user itself, because you just have a centralized system where you can see, I mentioned here, we have one node, but we can have a variable here and plotting all the different nodes we have and that we want to control. And yeah, this is where I see all the importance of this project.
This is pretty cool. I think Jeff put over there the link to the APN where you can see this solution over there. If you guys are curious to see how it works, I think it's super interesting, the journey that I went through with LuxQuanta on this one, because we were working together, and as Alba was very well saying, doing as infrastructure as code, right? Because they are not comfortable. Software people, software engineers, and system administrators are not comfortable clicking around a graphical interface that is going to change into weeks or into months, and you want to have everything in a place where you can just execute it and run it and see in text what's going on, right? And they have been super fast on picking up. This is an anecdote that I was very surprised that they picked so fast, that I was just giving them like a standard Linux image to build all their Grafana dashboards and all that stuff. And within a few days, without telling me, they were already using golden images to install all the software and everything that they needed in an image that it was theirs, so they could even make it faster for the next deployment. So the adoption is been super cool to see. At the end of the day, I think Alba hit the nail on the head. We don't need to know complexities of quantum quantum networks and quantum physics to operate these devices. We want to treat them as switches, as routers, as firewalls that are in our network, and you just want to figure out when they are not working properly, to maybe to bring the real expert and try to fix it, or just to reset it. And as Vanessa was mentioning, let it go back to its normal state by itself, right? So this reduces the complexity. And what we are doing here in AWS is trying to help LuxQuanta to make that a little bit easier for their customers and demystify the complexity of these systems.
Exactly. And this is the work that we are doing very thoroughly as well. It's just making sure that everything is automated, and this is bulletproof, meaning in case of any kind of problems with the power or whatever, the system can start itself. So the troubleshooting needs to be as transparent as possible for the final end user.
Great. If you're just tuning in, I'm sorry. Go ahead.
No, I thought that maybe I think that maybe if you have some questions from the audience or
real quick. Yeah. So if you're just tuning in, welcome to Howdy Partner, our weekly series on Twitch, where we bring our AWS partners and solutions hands-on directly to you. Today we're talking to Alba and Vanessa from LuxQuanta, and they were showing us how they use QKD to help safeguard our communications and data. So is this, we often hit over quantum, and there's a lot of theoretical around that word. Is this a real technology? Can our companies or enterprises, organizations really using QKD right now to secure the communications and data?
Yes, we can. So this is unlike quantum computers that are still increasing their capacity so they can start doing something truly meaningful, truly powerful. I mean, there is some work being done with them, but still, no, we are waiting for this quantum supremacy. Quantum key distribution is ready for deployment. So I'm actually sharing in my screen now how our system looks like. So Nova LQ was released last year in February, and this is the way that it looks. Is one of the two units that you get when you buy a system, a Nova LQ. Actually, this is summarizing what we've been discussing today. I think the best feedback that we've got from all the customers that we've been supplied to over this year and a half is that we've met expectations. And this, for the type of technology that we work with, continuous variable QKD is the best possible feedback, because this technology is meant to change the rule of the game. It should meant to make the deployments a lot easier. And we can, because we are using only one optical fiber for everything. So not only the quantum channel, that post-processing that Alba was referring about, everything could collapse into one single strand, optical fiber strand. No need to add anything else. And you can even tune it. So Juan was also talking about it. So the quantum channel can live wherever you need to. So you can actually coexist with data, even if it's very squeezed into the same optical fiber. It's also reliability and resiliency, mature components. So basically the stability of the systems is meeting our customer expectations. This has been installed in post-production networks. This is not something that is living in labs. This is living in real networks, and the feedback so far has been great. And then the maintenance is easier. All the components are off the shelf, very stable as well, because everything is automated. And it's delivering great performances as well in terms of the maximum link length. 60 kilometers is a nice, let's say, compromise for covering most of the links we have in metropolitan networks. But last but not least, Jeff, right into the question that you were asking, is proven. So again, a year and a half, these systems have been shipped to many countries in Europe, private and public entities, both, and also even across the ocean to the US. So we have here some relevant entities that I think says it all. No? So we've been working with local governments, for example, in our region, with the European Commission. The systems have been deployed for one of the, I would say, most ambitious projects in the whole world, which is the Euro QCI deployment. This is a project of the European Commission, co-founded by many private entities across Europe, that consists of deploying a backbone of this technology within each member state and across them as well, even complemented with satellites equipped with quantum key distribution, to have an infrastructure that protects the communications of the European Union for whatever comes, right? So proven is ready. If anyone wants to test this technology, we're supplying. Be in contact with us either through AWS contact website, or through our own as well. Either way, I will be very happy to assist you on this journey on the quantum realm. I think it's time.
So as a follow-up, so since it's proven, like, what do you see as the biggest challenge to widespread adoption to this QKD technology?
First of all, is familiarity, because everybody is more used to tackle the problem of this safe cryptography with a software approach. So the first thing is a change in paradigm. So right now you have to deal with hardware. So that I would say is just breaking this uncomfortable feeling of trying something that is new and learning about it. I think that if you have the right partner for that journey, that transition, it can be pretty smooth. And if you acquire the right technology, it should be quite transparent as well. It's similar to a switch, is what Juan was saying before, no? A router or a firewall, it should be very easy to install. The second step, this is something that we're working on very hard, and not only LuxQuanta, I would say the entire industry, is just making sure that these devices are is just ticking all the boxes. And one of it is standardization and certification. If we want these devices to handle restricted information, we need to reach out to a certain level of security. And there is a collective effort of the entire industry. Actually, the European Commission is funding this. We are in the right place actually to accomplish this goal. And that's something that we will have it on above the next couple of years. So to say, I think it's going to be there as well. The third problem I would say is supply, because we are coming to a change in the paradigm. I'm pretty sure. Like everybody's getting very restless. All the national security agencies, the biggest ones across the world, they are stating that we do have a risk that we need to start approaching or solving starting as of today. We are maturing, we are finalizing this journey of maturing this technology, so it ticks every single box. So we create certainty on the national security agencies that this is also fit for purpose, and that is a matter of time that it happens as well. And I think that supply is going to be challenging for all the QKD manufacturers across the world, because Alban mentioned this before. We're talking about thousands of units. Just only one single operator is a few thousands of them. So just scale this worldwide, right? And I'm not saying that this is going to be deployed for every single optical fiber link, even though still it's going to be challenging. So I think that the time is now. I think that we are at the right time with the right technology, and we have embarked upon the right journey, which is basically.
I think that part is part of the natural technology adoption of every new technology, especially when we are talking about hardware, right? I'm pretty sure that the Juniper Ciscos of the world went through something very similar at the beginning of the internet era, right? And we are going through that journey once again, but with all the lessons learned from that time.
Absolutely. Actually, you see more and more very large entities, so AWS is a fantastic example. Hard to surpass you guys in terms of size and relevance in the world. But there are also other system houses and other telcos, operators across the world that they are seriously, strongly looking into this. So we're going to see a lot of more news about any more entities, more different end users trying this technology, becoming familiarized with it, assessing where in their networks this makes a lot of sense, and then issuing as well roadmap of adoptions. This is some of the works that we are doing right now, is helping our customers to define what, when, so exactly in the network, where, so they can have a solid roadmap of adoption, so they are ready for when the threat is in our face, basically. No, it's too soon.
I'm gonna put you in the spot, and I'm gonna invite myself to show me your production chain. I want to see it.
Please, I mean, you're very welcome. Actually, I don't know if I said before, so we are Spanish based, but we are actually based in Barcelona, and we are by the beach. So this is something that we often say to our customers and partners. Is not only we have an excellent QKD technology, easy to install and very reliable, we actually can offer you a beautiful meal by the beach.
Jeff, you heard that?
Sounds like a site visit to me.
Yeah.
Business trip. We have to find the justification with our bosses.
Exactly. I can work on that. But it doesn't like we have many questions in the chat, and so I guess we can wrap up. But I want to say thank you. I really enjoyed learning a little bit more about quantum QKD. As Juan knows, I'm a budding quantum ambassador, so we talk very much about quantum, but actually seeing what's going out in the field and seeing your example and seeing the graphical interface of how you can actually see the noise was greatly appreciative to me. So thank you. So that's what my favorite part about the show. Hassan, being that we aren't anywhere near quantum experts as our other three guests, what was your favorite part of the show?
Yeah, no, I definitely agree with you. I barely had that much knowledge coming into the call about quantum, and yeah, the overview was super helpful. I can already kind of start thinking of some ways we can integrate it with other AWS services, even like in that dashboard Alba was talking about, like maybe one of our anomaly detection services, like Lookout for Metrics, or like integrating SageMaker there, just to make things even more easier when in terms of just scaling that adoption, getting more people to use the QK and still have that monitoring capability. I can definitely see why it's going to be more of a widespread thing going forward. Really appreciate the discussion.
Thank you guys for the invitation. This has been a very interesting, I think, 360 conversation. So thanks so much for the opportunity to be here and tell the world about the work that we've been doing with you guys. It's been an incredible journey, professionally and personally. I think you make a great team. So thanks for the invitation once again, and thank you, Juan, for the work as well that we've done together.
Yes, thank you.
You got it.
Yeah, I was going to say thank you for giving us a glimpse into the future, but thank you for giving us a glimpse into the present. And
Oh yeah, I like that, Jeff. The
Yes.
message then is out there.
yes. All right. So for our viewers, make sure you tune in next week at the same time, same channel to view our next partner solutions. And I'm happy to have you, and we'll be signing off now. Thank you.